Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is the procedure programming module, and the same chapter, that is the chapter number 18, that is the graphics under the Windows. That is how to use the graphics under the Windows. In the last class we have discussed about the graphics, that is how to use the graphics under the Windows. Let's talk about the previous class, what we have covered in the previous class, then moves to the next part, that is the today's topic. So let's start with the previous session, that is the last class session. In the last class we have discussed about the topic, that is the codes and the reuse resources. That is what is the code and what are the resources that is available in the program. So a program consists of both the instructions as well as the static data. So whatever the data and whatever the instructions, they forms the program. Since or static data is that portion that is not executed as the machine instructions, and which does not change as the program executes. So that does not change when the program executes. So it does not change whenever there is a requirement of the program. Static data as the character strings. We have discussed like character strings due to the character bitmap, fonts, etc. So in Windows term, this static data is simply known as, or its another name in the Windows is simply resources or the resource data. So this is the resources. That means whatever the data that is available in the program, whatever the static data, that is known as the resources in the Windows. What is the code? That means simply when whatever we write, whatever the set of statements, whatever the set of instructions, that is known as the code. So a program is a set of the instructions as well as the static data, that is the resources, or simply resources. So this says separating the code from the resource has other advantage like reducing the memory demand. So whenever we separate the code from the static data, code is different, static data is different. So this also gives an advantage. What is the advantage? That is to reduce the memory demand and making the programs more portable. That is, the programs becomes more portable. We can port the program from one part to another part. It also means that a programmer can work on a program logic while a designer work on how the program looks. Then the next topic is freehand drawing the paintbrush style. That is how to do the freehand drawing using the paintbrush style. So this paragraph, what we have discussed, is saying whatever we did, that is the types of the pens, the types of the brushes, but the main concern is available in the freehand drawing, or it is also available for the freehand drawing. So we can indicate when the freehand drawing begins by clicking the left mouse button. Then as we move the mouse on the table with the left, the freehand drawing should get drawn in the window. So whenever we click with the windows, whenever we click with the mouse, there is a freehand drawing that is available under the windows. This drawing should continue till we do not release the, or till that we do not release the left mouse button. And then we have also discussed that there are so many inputs that comes in different types of messages that is available. For freehand drawing, there are three kinds of messages. What are the three kinds of mouse messages? One is the WM left mouse button, one is WM mouse move, one is WM left button up. So these are the types of inputs that is available for the messages, or these are the types of messages that is available in the freehand drawing. What are the three types of messages? One is the left mouse button down, one is the mouse movement, one is the L button up, that is for releasing the mouse button. Then we have discussed about these messages, that is how to use these messages, and how the window procedure functions are using or how the window procedure function is able to handle the messages. So these are the various variables that is declared over here. Then this is the function, that is the L result function. There is a callback function, there is a window procedure. Then these are the various parameters and that is used. One is the HWND, one is the message, one is the W param, one is the I param. Then there is a switch message, that is the switch case is used. The same cases, one is WM destroy, one is WM left mouse button. So if there is a destroy case, simply calls the function that is on destroy function. And whenever there is a case of the L button down, that is pressing the button of the left mouse, that is pressing the left mouse button, then that is a case of the WM left button down. Then there is a case of the WM left button up. Then otherwise it is a case of left button move. So these are the various cases that is available. One is destroy, one is the button down, one is the button up, one is the mouse movement. If nothing is the case, then there is a default case. What is the default case? That is returns the default window procedure. That is simply returns the default window procedure that is available. Then there is a return 0. Then these are the definitions that we have discussed. That is this is the definition for the L button down. That is whenever we click on the with the left button, that is the L button down. This is the how to do the mouse movement. In this we have used the L button or the flags equals to MK L button. These are the various code that is available whenever the condition is true. Then this is the on L button up, then there is a release capture. So whenever we execute this program, that is how to use the freehand drawing, the output shown like this one. This is the freehand drawing. So this comes from there, here, here. This is the freehand drawing. Then we also discuss what is the use of the set pixel function, that is for setting the pixels, how many coordinates are available and what is the range where the pixel is used. And pixels are the tiny elements, small elements that is available under the windows. Then we have discussed what is the use of the WM left mouse button that arrives with the window procedure, on left mouse button or on left button down, I param. This is the I param. Then low word, high word macros that differentiate the XY coordinate from the I param. Then on left mouse button or L button down, that we have preserved the starting point of the freehand in the global variables. Then on mouse move button, that is also gets called whenever we check whether the left mouse button stands suppressed or stands depressed. So if it stands depressed, then the variable also contains the MKL button. If it does so, then the current mouse coordinates are set up in the global variable, that is x2 and the y2. We have discussed. Then there are two more functions that is used. One is move 2x and one is line 2x. Then we have also discussed about that is how to capture the mouse, that is capturing the mouse. This is also the topic that we have discussed. That is how to capture the mouse. For capturing the mouse, where we have various functions like on left button down, set capture function is used. That is also an API function that is used for capturing the mouse. That is a set capture. And for releasing, that is whenever we use the L button up, we are calling the function that is a release capture API function. One is a set capture, one is a release capture. Now let's move to the today's topic, that is a device context. That is how to use the device context in the Windows programming. That is what is DC in the Windows programming. Now this says that is till now we have written a few programs that are comfortable with the idea of selecting objects like font, pen, brush into the DC. That is till now we have discussed what are the types of pens, what are the types of brushes, what are the types of fonts that is available into the DC. Now it is a time for us to understand how Windows achieves the device independent drawing using the concept of DC. That is how Windows achieves the device independent drawing, how we are able to achieve the device independent drawing using the concept of the device context, that is a DC. So a DC is nothing but a structure that holds handle of various drawing objects. So DC is a structure, is a framework, is a base that holds how to handle various objects, various drawings objects like font, pen, brush, etc. That is how to handle these objects, or how to deal with these objects, like what is how to handle the brush, what is the type of brush that is used, how to handle the pen, how to handle the fonts like Times New Roman, Arial, that is available, or that is becomes the base for all these elements. That is a DC. Now a screen DC and its working, that is how to display on the screen, that is how to use the fonts, is shown in figure 18.6. So this is the figure that shows how to use the DC in the Windows. There are two applications. This is the application 1, this is the application 2. There is a screen DC, this is a screen DC, this is again the screen DC. In this there is a H pen that has 200 pixels, H brush 400, H bitmap 600, H font 700. So this is the screen map screen DC pixel measurement. This is 200, 400, 600, 700. This is the other information. Then there is the application 2. This is the application 2. There is a screen DC. There is a H pen, that is 900, H brush, that is 1000, H bitmap 600, H font 800. So these are the various dimensions in pixels that is used, and this is the other information. Now this comes over here, this comes over here. There is a screen, that is the output device that is used to display the output over the screen. Now there is a drawing object, this is the drawing object, that is how to draw the object. If it is using the font as a Arial, then H font is equal to 700. This is the Arial, then H font is used as a 700. This is a drawing object, there is a red pen, there is a blue brush. So one application is using the font, another application is using the pen style as well as the brush style. So if it is a red pen and it is of blue brush, so this is of 900, this is of 1000. Now there is a black pen and there is a white brush. There is a mono bitmap, there is a font. This is the default drawing object. So this is the diagram that shows how it works. So this says a screen DC, that is a screen DC that is available, and its working is available over here. Its working is how to display over the screen, how to get the information in pixels, that is done by the screen PC. This is for black pen, this is white brush, mono bitmap, font. These are the various dimensions like 200, 400, 600, 800. You can make the following observation from this diagram. The DC does not hold the drawing objects like pen, brush, etc. It merely holds their handles. That is, the DC does not handle the font style, types of pens, types of brushes, nothing, but it only holds the pixels, that is a dimensions. With each DC, a default monochrome bitmap of size 1 pixel x 1 pixel is associated. For each DC, there is a size of 1 pixel is associated, that is the size of the by default, that is a monochrome bitmap, that is this one. Right. Default objects like black pen, white brush, etc. are shared by different DC in same or different application. These are the default drawing objects that can be shared by multiple applications by multiple DCs. So this black pen is shared by application 1, by application 2 also. Application 3, any type of application will be shared by the or shared from the default drawing object, but it cannot be shared from the simple drawing objects. No, it only shares with the default drawing objects. Then D point says the drawing objects that an application explicitly creates can be shared within the DCs of the same application. That is, whatever the drawing object that an application is sharing or that an application creates can be shared within the DC of the same application, but it's never shared between different applications. That is, DC is shared by the same application, that can be shared, or application is shared by the same application, and that is never shared by different or between different applications. Next point says two different applications would need two different DCs even though both would be used to draw to the same screen. That is, if there are two applications, that is application 1, application 2, that needs two different DCs like screen DC, one screen DC, one screen DC. Even though both would be used, even though both collectively will be used or would be used to draw to the same screen. That is, if there is a step or there is a step or there is a possibility that the two DCs or two screen DCs, application screen DC, must be available to draw to the same screen. That is, they are also able to do draw to the same screen. In other words, with one screen, multiple DCs cannot exist. That the same screen cannot be shared by the multiple DCs. So this is the main point, that is two different applications would need two different DCs. Next point says, last point says, a common device driver would serve the drawing request coming from different applications. So if there is a different application, so the common device driver will be used to draw the different objects to draw the different application to serve the different application. Truly speaking, the request comes from GDI function that our application calls. Now, next line says screen and printer DC is okay, but what purpose would a memory DC serve? That is, what is the purpose of the memory DC? Why it is available in the memory? Well, that is what the next program would explain. That is, what is the purpose of the memory DC? How or why we are using the memory DC in the screen or within the screen. Now, next topic is displaying a bitmap. That is, how to display a bitmap in the DC. So we are familiar with drawing normal shapes on screen using a device context. Now let's see how about drawing images on the screen. That is, how to draw the images on the screen. Windows does not permit displaying a bitmap image directly using a screen DC. That is, we are not able to draw a bitmap image with the windows or under the windows by simply drawing the images on the screen. Windows does not permit displaying a bitmap image directly using a screen DC. That is, we cannot display the image with simply using a screen DC, that is a screen device context. This is because there might be color variations in the screen. That is, there may be a different color combinations, different color variations in the screen on which the bitmap was created and the screen on which it is being displayed. That is, there may be a different part or there may be a different issues, there may be a different variations in which the bitmap was created and the screen on which it is being displayed. To account for such possibilities while displaying a bitmap, Windows uses a different mechanism that is known as the memory DC. So whenever we want to display a bitmap on the screen with the help of Windows, we cannot able to do it directly with the screen DC. But for this, instead we have to use the memory DC for displaying a bitmap on the screen, for displaying a bitmap images on the screen with the help of the memory DC. The way anything drawn using a screen DC goes to screen. That is, the way whatever we used or whatever we drawn using a screen DC goes to a screen. Anything drawn using a printer DC goes to printer. So the way anything is drawn using a screen DC goes to a screen. Anything that is drawn using a printer DC goes to a printer, and similarly anything that is drawn using a memory DC goes to the memory. So whenever we use the memory DC, so everything or anything that is stored with the help of the memory DC would be stored in the memory only. That is stored in the memory. That is a RAM. But where in RAM? What is the location where it is stored in the RAM? In the 1 by 1 pixel bitmap whose handle is present in the memory DC. That is available in the RAM, that is available in the 1 by 1 pixel bitmap. Note that this handle was of later use in case of screen printer DC. Therefore, if we want to or if we attempt to draw a line using a memory DC, it would end up on a 1 by 1 pixel bitmap. Therefore, if there is an attempt to draw a line using a memory DC, so it would end up with the 1 by 1 pixel bitmap that is available with the 1 by 1 pixel bitmap. You would agree that 1 by 1 is too small a place to draw even a small line. I agree that 1 by 1 is one of the smallest line, that is one of the smallest image that is available to draw a small line. Hence, we need to expand the size and color capacity of the bitmap. That is, we need to or we are able to expand that size and the color capability of this bitmap. How can we do this? Just replace the handle of this one with the handle of a bigger and colored bitmap object. So we can simply replace the handle of this 1 by 1 pixel with the new bigger and the colored bitmap object that can be shown with the help of the figure 18.7. So now let's see how it is able to handle more than one screen, or how it is able to handle bigger and the colored bitmap object. This is a default memory DC, that is a default one that has different dimensions, like HPen has a 200 pixel, HBrush has a 400 pixel, HBitmap has a 405 pixel, HFont has a 800 pixels, and this is the other information that is available regarding HPen, HBrush, HBitmap, HFont. And this is the HBitmap that is only used over here. This will be occupied, or this will be using the default output device, that is a H05, that is 1 of 1, that is 1 by 1, that is 1:1 monochrome bitmap. This is a black pen that is used, that is of 200. White brush, this is the example. Black pen is of 200, white brush is of 400, font is of 800, like this one. This is of 200, H pen, that is of 200 black pen, H brush, that is of white brush 400, H bitmap, that is of default output device. This is the default output device, that is 405. Then H font, that is of 800, and this is the default drawing objects. Like this is the default memory DC that is available in the memory, that is available in the RAM. This is the memory DC after selecting bitmap. That is, what is a memory DC that is used after selecting the bitmap? There is a H pen, that is a pixels 200, H brush, that is a 400, H bitmap, that is a 40,000, then H font, that is a 800. This is another information, that is a memory DC after selecting the bitmap. This is my requirement, that I want to display a eagle on this, or a bird on this device, on this screen. So this is not sufficient. Why? This is default, that is 1 by 1, but my picture is not available in 1 by 1, that is not properly fit into the 1 by 1. So I need to expand that one. That is how to expand, how to give the colored image. This is the concept, that is a memory DC after selecting the bitmap. Else everything is same. This is 200, this is 200, this is 400, this is 400, this is 40,000, this is 40,000, this is 800, this is 800, this is for 40,000, and this is the concept, that is 190 into 220, 24 color bitmap. This is another concept, that is a 24 color bitmap image, that is 190 into 220. What purpose would just increasing the bitmap size color would serve? That is, what is the purpose, what is served, that is the increasing the bitmap size and the color. Whatever we draw here would get drawn on the bitmap, but would still not be visible. We can make it visible. That is how we can increase the bitmap size color but that cannot be, or that cannot be shown with the help of the screen. But we can make it visible by simply copying the bitmap image. We can simply use it by simply copying the bitmap image to the screen DC by using the API function. Which API function is used? One is the bitBLT function. This is the API function that is used. Before transferring the image to the screen DC, we need to make the memory DC compatible with the screen DC. So before transfer the image to the screen DC, this is transferring the image to the output device, that is the screen DC. So first of all, there is a compatibility between the memory DC and the screen DC. Here, making compatible means making certain arrangement, making certain conditions, using certain rules and regulations, that is making certain adjustment in the content of the memory DC structure. That is, we are using the different capacities, different adjustment that is available in the memory DC structure. Looking at these values, the screen DC driver would suitably adjust the color, that is, it suitably adjusts the color of the eagle when the pixel in the bitmap of memory DC is transferred to the screen DC using the bitBLT function. So this bitBLT function is simply used to make the compatibility between the screen DC and the memory DC. So this is used to make the compatibility between these one. Right. Then let us now take a look. So let us now take a look of this one program that put all these concepts in action, that puts that how to use these concepts in action. This program merely displays the image of a vulture in a window. That is, this program would give a vulture of the image of the vulture in a window. What is the code? Or here is the code. The same onPaint function is used, that is done, or that is used by the void. That is, the return type is void. So there is a void onPaint, then hwnd, hwnd. So these are the variables that is used, that is the hwnd and the hwnd. Then there are various data type that is used. One is HDC, HDC, HBitmap, HBitmap, HDC, memory DC. One is HGDIOBJ. One is hold BMP. One is the paint struct. One is the PS. So these are the various concepts that is used over here. That is a paint struct. Then the same HDC is used for storing the output of the begin paint function. So this is the begin paint function. So this is the begin paint function. The output of this is stored in the HDC. Then there is a load bitmap. The output of this is stored in the HBMP. This is HWND and the &PS. Then H instance make inter source. This is IDB bitmap 1. Then this is the another variable that is used, that is the HMemoryDC. This is the HMemoryDC that is used to store the output of the create compatible DC. This is the new function that is used, that is a create compatible DC. And the variable that is, or the argument that is used, is the HDC. Then there is a hold BMP for holding the bitmap, that is able to store the output of the function. That is a select object, and there are two arguments, that is the HMemoryDC and the HBMP. Then the same function is used, that is the bitBLT function. And these are the various arguments in this. One is SDC, 10, 20, 190, 220. So these are the various parameters that is used in this. One is HDC, one is 10, one is 20, one is 190, one is 220, one is HMemoryDC, 00 SRC copy. So this is the source copy. and these are the various dimensions, these are the various parameters that is used in the bit BLT function. And then there is a end paint. This is the end paint function that is used over here for ending the painting. Then in the end paint there are two parameters that is used. One is the HWND and the ampersand PS. So these are the various functions that is used. One is the begin paint, one is the load bitmap, one is the create compatible DC, one is the select object, one is the bit BLT, one is the end paint function. Then select object function is used that has two arguments. One is the H memory DC, one is hold BMP. So the output of this one is create compatible is stored in the H memory DC, and the output of this is stored in the hold BMP. And both these variables are used as an argument of this, that is a select object. So select object contains both output, that is a create compatible DC and the select object. Then there is a delete object function is called, that is storing the argument as a HBMP. Then there is a delete DC, and there is an argument that is a H memory DC. Then there is a closing of the curly braces. So these are the contents of the onPaint function. There are various variable declaration. Functions is used and store the output of the functions in various variables like HDC, HBMP, HMemoryDC, that is HMemDC, hold BMP, and the PS. And one more function, important function is used, that is a bit BLT function, that is also a API function. So whenever we execute this program, the windows looks like this one. Simply to display the bitmap, we are using this one. This is the bitmap that is used, or that is used to display with the help of the C programming. As usual, we begin our drawing activity in the onPaint function by first getting the screen DC using the begin paint function. So this is the explanation, that we are simply works with the same flow, that we begin with the onPaint function, that is the first function that is used, that is the onPaint function, by first getting the screen DC using the begin paint function. Next, we have loaded the vulture bitmap image in memory by calling the load bitmap function. So next function which is used, that is a load bitmap function, that is used for loading the bitmap image, and the output is stored in the HBMP. Next, we have loaded the virtual function, this one. Its usage is similar to what we saw while creating a pattern brush in an earlier section of this chapter. So when we discuss about the brushes, there is a brush, that is a last brush, that is a pattern brush. For that we also need a bitmap image, and for this one, that is for displaying a bitmap, we also use bitmap image. The same concept for loading the bitmap. Then we have created a memory device context. Then after loading the bitmap, that is done by the load bitmap, we have created a memory device context, that is a memory DC, and its properties, that is compatible with that of the screen DC. To do this, we have called the API function that is known as the create compatible DC. So this is again the next function that is used, that is a create compatible DC function. Note that we have passed the handle to the screen, that is DC, to this function. This function in turn returns the handle to the memory DC. That is, we have passed the handle to the screen DC to this function. Then this function in turn returns the handle to the memory DC. That is, first of all, it passes to the screen DC, then it passes to the, or it handles to the next term, that is the next part, that is a memory DC. After this, we have selected the loaded bitmap into the memory DC. So after this, this has been passed to the memory DC. So one is the load bitmap, one is the create compatible, then select object, then bit BLT function is used, then the end paint function is used. After this, we have selected the load bitmap into the memory DC. So these are the various steps. First of all, onPaint function is used, then begin paint function is used, then load bitmap function is used, then create compatible DC function is used, then load the function or load into the memory DC, then load the bitmap into the memory DC, then copy the bit by bit transfer by from memory DC to the screen DC, that is from memory. First of all stored in the memory, and for displaying purpose we have to display on the screen, that is transfer to the screen DC, that is provided by the function that is a bit BLT. So this bit BLT function is used to transfer to the next screen or to transfer to the screen DC using the function that is a bit BLT function. As a result of this, the virtual now appears in the Windows. That is how it appears in the Windows, or this vulture or this eagle that is appears in the Windows. This is the most important function, that is the bit BLT function that is shown in figure. This is the bit BLT. These are the various arguments. This is HDC 10, 20, 190, 220, H memory DC 00, SCR copy function. Now let us understand its parameter. Now let us understand the parameter. What are the parameters that is used over here? These are as under. What are the parameters? One is the HDC, handle to the target DC, where the bitmap is to be bleated. Then 1020, position where the bitmap is to be bleated. 190 to 100, that is the width and the height of the bitmap being bleated. That is these are the various parameters that is used over in the built BLT. This is the function. This first of all there is a HDC, then 1020, 190, 220. So this is the HDC that is handled to the target DC. That is how to handle the target DC. Then there is a 1020, that is a position where the bitmap is to be bleated. That is where the bitmap is to be used. That is a 1020. Then 190, 220. That is the width and the height of the bitmap being bleated. That is what is the width and what is the height of the bitmap being used. That is the 190 and the 220. Then there is a 00, that is the top left corner of the source image. If we give 1020, then the image will be displayed from 1020 to the bottom right corner of the bitmap would be or would get bleated or would get appears. This is 00, that is the top left corner of the source image. Then next one is your last argument is your SCR copy, that specifies one of the raster operation code. That is a raster operation code that is available, that is a SRC copy. These codes defines how the color data for the source rectangle is to be combined with the color data for the destination rectangle to achieve the final color. So this code is used, or these codes used to define how the color objects for the how the color data for the object or for the source rectangle is to be combined with the color data for the destination rectangle. That is how it is used with the source rectangle and how it is used with the destination rectangle, and how to achieve the final color. Then next point says SRC copy means that the pixel color of the source should be copied onto the destination pixel of the target. That is the pixel color of the source, that is the SCR or SRC copy, that is the pixel color of the source should be copied into the destination onto the destination pixel of the target. Then animation and work. This is the next topic, that is how to use the animation at work. So first of all, let's take 5 minutes break only. This is only 5 minutes break because today the session is too small. So let's take a 5 minutes break because I'm so tired. I have taken the class from 3 o'clock continuously. So let's take a break for 5 minutes, then move to the next topic, that is animation and work. So let's come back from the break. Let's start with the session. that is the animation at work. That is how to use the animation at work. That is how to use animation in the bitmap images, how to use the animation in the content of the graphics. So this says speed is the essence of the life. That is, speed is the essence, or speed is the main part of the life. That is the best part, or that is the one of the important part of the life. That if the speed is there, then we can achieve each and everything in the image. That is, the speed is the essence of the life. So having the ability to display a bitmap in the windows is fine. So it is the ability to of the using the bitmap is fine, but if we can add movement and sound to it, then nothing like it. That is, if we can add the animation and if we can add the sound to it, then nothing is like that, or nothing we can add to it, or nothing is like that. So let us now see how to achieve this animation and the sound effect. That is, how to give the animation, how to give the movements in the graphics, and how to use them using the work, how to use them in the work. That is, how to use the animation at the work. So now let's see, if we are if we are to animate an object in the window, we need to carry out the following steps. That is, these steps must be carried out if I want to animate an object in the window. So what are the steps that is available? The first step is create an image that is to be animated as a resource. That is, create an image that is to be animated, or that is used as an animation as a resource. Then prepare the image. Then prepare the image for the later display. That is, also prepare the image. First of all, create the image that is to be animated as a resource. Then prepare the image for the later display, that is used for the later display. Then repeatedly display this prepared image at suitable places in the windows. That is, on a repeated basis, display the prepared image. That is, what the image that is prepared, that is the animated image, at the suitable places that is available in the window, taking care what the next image is displayed when the previous image is erased. So taking care of that part, or taking care of the fact that it is displayed at the suitable places, so that the next image will arrive in a positive sense, or in a simple sense, in a simplicity, so that the next image displayed when the previous image is erased. Then last point is check for collisions and while displaying the prepared image. Then check for the collisions, that check for the errors, check for the collisions. So these are the various steps that is available to animate an object. The first one is creating an object or creating an image that is to be animated as a source. Then prepare the image for the display, for later display. Then repeatedly display the prepared message at suitable places in the windows. So first of all, so the first step is simply creates an image that is to be animated as a resource. Then second point is simply prepare the image for the later display. Then repeatedly display the prepared image at a suitable places where it is used. Then check for the collision while displaying the prepared image. So these are the various steps that is available whenever we use the animation, or whenever we use the animated in the animations in the graphics. Now let us write a program that on execution makes a red color ball move in the window, so that we are able to create a, or we are able to write a program that is, when executed, makes a red colored ball move in the window. That is how a red color ball moves in the window. That is the main part. So let us write a program for that part. As the ball strikes the walls of the windows, a noise occurs. That is, whenever a ball strikes on the walls of the window, a noise occurs. That is also animated part. Note that the width and the height of the red color ball is 22 pixels. that is the height, and the width of the red color ball is of 22 pixels, that is available. Given below is the window procedure function. So one is using the window procedure function and the various messages handles that help achieve animation and sound effects. That is what is the window procedure function that is available, and what are the messages and what are the message handlers that is available that is able to achieve the animation and the sound effects. So what is the information that is available? This is the program. These are the various variables that is used. This is h bitmap, hbmp, int xy. Two variables are used that is of integer type. This is hbmp, that is the h bitmap. Then there is the hdc, there is the h memory dc. That is the h memory dc is used. Then sg diobj hold bitmap, that is the hold bmp. That is the hold bmp is used. So these are the various variables that is declared over here. Then L result, callback, Windows procedure. That is a L result, that is a result to be given. Then there is a callback. Then there is a Windows procedure. So after using the Windows procedure, these are the various parameters that is available over here. What are the parameters that is available? One is the HWNT. Then there is another variable is uint, that is of integer, that contains the variable as a message. Then wparam, then lparam or the iparam. Then again the same, the switch message is used, that is the switch case is used, and there are different cases. If it is a case of the destroy, that is a wm destroy, then a function is called, that is the on destroy function, that has a value hwnd. Then there is a break. And if it is a case of create, there is a function that is called, that is a on create function. Again there is a break. If it is a case of timer, that is timer is given, that is a timing is given for the animation for movement, then on timer function is used, then there is a break. If it is not a case of the wm destroy, and if it is not case of the wm create, if it is not case of the wm timer, then it is a default, that is a default will be returned, that is a default window procedure. And these are the various arguments of the default window procedure, that is hwnd, message, wparam, iparam. So these are the various cases that is available. Then there is a return 0. So this is the switch case, and this is the closing brace for the L result. This is the on destroy function, and this is the definition of the on create function. Why there is no definition for the on destroy? Because this is same in each and every case. We have already discussed about the on destroy function. So this is the case of the on create function. So there are two variables that is declared. One is the rectangle, that is a rectangle, that is has a variable r. One is the hdc, that has a variable hdc. Then there is a hbmp. This is also a variable that is able to store the bitmap file, that is a load bitmap. And these are the various arguments. One is the h instance, make inter source, and this is the argument of the make inter source, that is the idb bitmap. Then this is again the variable that is used, that also contains the output of the function, that is a get dc. So this get dc is also a function that is a parameter, that is the hwnd. So this is the on create function that is used. This is the explanation, or this is the definition of the on create function. There are various arguments. There is a variable that is able to store the bitmap file. Then there is again the variable that is the hdc, that is able to store the output of the function, that is a get dc function. Then uh, this is the h memory DC, that is the next variable. Then create compatible DC. This is the function that is used, and the output of this function is stored in the h memory DC. Then again the next one is select object, and the output of this is stored in the hold BMP. And there are two arguments in this, that is the h memory DC and the h BMP. Then there is a release DC, that is releasing of the device context, that is also contains two variables, that is the HWND and the HDC. Then SRAND, this is the one argument is used, that is of time, that is a null as an argument. So these are the various functions that is used. Then next function is get client rectangle, that is that get client rectangle, that is getting the client rectangle of the client, and this is the variable that is used. This is the variable that is used. What are the arguments? One is the HWND and the %r. This is the address operator that is used. Then x equals to rand function modulus r dot write minus 22. So this is the way how we are giving the margins, or how we are giving the dimensions, that is rand modulus r dot write. In the same way, rand function modulus r dot bottom. Then there is a set timer function that is used, that has again various arguments like HWND 150 null. So these are the arguments that is used for the set timer function. So this is the definition of the create function. This is the definition of the onCreate function. That is how to create the animation. That is how to create the various cartoons in the animation. Then next function is of destroy function, simply destroying the object, destroying the animation that is used. The first function that is used is the kill timer. Then there is a function that is used is select object, then delete DC, delete object, then post quit message. So these are the various functions that is used in the on destroy. One is the kill timer, then select object, delete DC, delete object, post quit message, and then there is a closing of the curly braces, or closing of this function. Then next is your void on timer function. So one is your void on destroy function, one is your void on timer function. This is of on timer. Again there are two arguments of this. The one argument, sorry, not two argument. One is HWND and the HWND. Then again the variables are declared. One is of HTC, then rectangle, that is R, then constant int WD, that is width equals to 22, height equals to 22. Then static, that is dx equals to 10, dy equals to 10. That is also a dimensions of the x and the dimension of the y. Then again uses the variable that is HDC, that contains the output of this function, that is the getDC is the function, that is the argument, that is the HWND. Then again the same function is used for displaying the animation, for storing the memory DC into the screen DC, that is to display on the screen, that is the bit BLT function. That has again the arguments, again the 10 arguments, that is HDC, XY, WT, that is the width, height, then HMemory DC 00, whiteness, that is the color. So these are the 10 arguments that is used. Not 10, this is 9 arguments, 1 2 3 4 5 6 7 8 9. Yeah, these are the 9 arguments. Then the function that is used is the get client rectangle function, that again has two arguments. One is the HWND and the %r. then this is used, that is x plus equals to dc, that is every time x will be incremented to the dc. Now check the condition. If x is greater than 0, that is it will work when it is greater than 0. That means it cannot work for 0, it cannot work for values less than the 0. It works for the 1, 2 and more than the 1 values. So if it is a condition, then x has a value or given the value as a 0 and dx is given the value as a 10. Then there is a play sound, that is also a function that is used, that is a play sound. So play sound is also a function that has different arguments. One argument is code.wav. This is a wave file that is used, that is only for playing the sound. This is the name of the sound file. What is the name of the sound file? That is a code.wav wave file. Then null, then send file. This is the send file. This is the send asynchronous NC. That is async. Else, if it is less than 0, sorry, if it is greater than 0, now if it is greater than or less than r dot write minus wait. That is, what is the r dot write? This is the r dot write. That is the right angle. If it is less than minus width, then x is assigns a value of this one, that is x r dot write minus width, and dx is assigned the value as a minus 10, that is it is going to the negative part. Then again uses the play sound. The play sound function is used, and again give the name of the sound file, that is the code.wav null send file name send async. This is the next part. Now uses for the y syntax, y coordinate. It is for the x coordinate and this is for the y coordinate. That is y plus equals to dy. If, now check the condition again, if y is less than 0, so if it is less than 0, then y is given the value 0 and dy is given the value 10. That is, both the values are positive value. Again uses the play sound, the same name of the file, the same parameters are used. Else, again if this is the part, then it's okay. Otherwise, that is the else. If y is greater than r dot bottom minus ht, that is a height, then check, that is y equals to r dot bottom minus ht, then dy equals to minus 10. Then play sound, that is code.wav, again the name, same name of the file, same name of the sound file, that is a code.wav. Then uses the bit BLT function, that has the same argument, HDC, x coordinate, y coordinate, width, height, h memory DC 00 SCR copy. This says from the window procedure function you can observe that we have handed two new messages, that is a WM create and the WM timer. So these are the new function that is available, that is a WM create function and the WM timer function. For these messages we have called the handlers, that is on create function and the on timer function respectively. Now let us understand what is the use of WM create and what is the use of on timer function. This is the WM create and this is the on timer function. So these are the explanation of this topic, that is that how to use the WM timer, how to use the WM create function. So now tell me, if I stop over here and moves to your doubts, that is sending the mails to this one and how to get the VC++, or can I continue with the practical approach so that I can run at least one program or one or two programs? So it's your choice. If you think that, if you need that, I will mail you the email of the slides or slides of the computer system, then I will stop over here, Otherwise, I will continue. So tell me, it's your choice. Hello, yeah, are you able to hear me? Yeah, Larry. Yeah, Larry, I will hear you. Hello. Now it's okay. Hello, hello, hello. Uh, so let's see how to get the VC++. Okay, all right. And what about OLSM? OLSM, okay, all right. So let's stop over here only, and I will show you that how to use that one. Okay, so just a minute. Yeah, everyone, are you able to see my screen? Larry, are you able to see my screen? Yeah, yes, yes. No, no, no. You are able to see this one, C programming, C Windows programming tutorial, let lesson 1. No, no, no. Yes, yes, yes. So these are the steps how I can run the VC++ program, Windows programming. Okay, Olesam. So this is the lesson number 1, how to use this one. You can simply download from the internet. So this is the file I will share with you. This is a PDF file. I can save it on the screen. I can save it on the desktop, and I will share with you. This is the Windows. Where is the desktop? This is also a desktop. So this will alive like Windows programming. This is the PDF I will share with you. And after this, you will see. For this purpose, you are able to get, or you want to for this you want to download this Dev C++. That is, you must download this Dev C++. And how this will be downloaded? This is the steps. These are the steps how this will be downloaded. Simply you use Dev C++ in the Google, and these are the various options that is available. You can select any option like this one, and these are the steps available. These are the requirement that is available. That is, it is required at least Windows 95 or higher, 32 GB of RAM. This is the license, so you can download it from here. You can download it from here. You can download it from here. So the main point is that you want the Dev C++ for this one. You can also download from here. This is also a source code that is available. Alright, so first of all, go to this one. In this, the first step is, if you have not started Dev C++, do so now. Then after downloading this one, this will be the window. Then select the file, then new object, then give the name, use the properties, give the enter the code in this one, like this one. This is the same code what we have discussed with the help of the book. Then press the F9 to compile it, and this is the output how it will show, and this is the explanation of the coding. So this PDF I will share with you, and these are the various chapters, that how to understand the messages, how to deal with the messages. These are the various steps, these are the various chapters. But for your purpose, from till point of time, this is the important chapter, that is chapter number 1. That is the first Windows program, how to use it. But the main concern is that for using this, you want to download it, or you have to download the Dev C++ from the internet. How this will be downloaded? This will be downloaded from here. You can download from here. You can download from here. These are the various versions that is available over here. Now, Larry, tell me, your doubt is clear how to do the Windows programming. Yes. Yeah, first of all, download the Dev C++, then follow these steps, and then after following these steps, you are able to get the output, but you have to write the code over here like this one. All right. So I will share with you. Just a minute. What's your ID? This one. Awesome. Do you know? Do you need this? Okay. Okay. The subject is Windows programming steps. Okay, Joseph. Joseph, you also need this. Okay. All right, Joseph. I will mail you. Windows programming steps. I will attach this file from the desktop. That is a Windows programming PDF. All right. Now, tell me any other doubts? Yes. Yeah, yeah. I am able to hear you, Larry and Joseph both. Hello. Pardon? One by one. You are Joseph. Yeah, Joseph, tell me. Okay. Yeah, yeah, yeah. First one does not exist. I think. Okay, okay. All right. All right. Just a minute. Okay. This will be sent to you. Sent. All right. Now, any. Okay. Any other doubts? Now, question. Yeah, Larry, tell me. Hello. Yeah, Larry, tell me. Yes, yes, tell me, Larry. No, no, no. That steps are not available. You can simply download from the internet by following these steps that is available in the PDF. No, no, no. You have to download first of all Dev C++ from the internet like this one. You can simply write Dev C++ on the Google, right? Then there are different options available. You can download from anywhere. You can download from the like this. Hmm. Okay. So so look my so look my screen. I've written Dev C++ in the Google, right? When I click on this, there are multiple steps. You can use this one where I click. You are able to see this one. Sim Simply right click. This is the screen that is available over here. This is in processing. You can download from here. This is the Dev C++. You can download from by clicking on this button. Okay? And these are the various steps of. Yeah, this is the fourth link. This is the fourth one. Now, my doubt comes to the OLSM. OLSM, you need the PPTs for the computer system, right? Hello. Yeah, OLSM. Yes. So I will send you. Yeah, Joseph, don't worry. I will complete your course within the time. No issues. Because uh, at least for C programming, this is very important for uh, giving the time in this. Because if I finish this course in speed by speed, so there is no time to hurry this one. Because if I give 2 months, then it's okay. These are the few mainly module or the hardly module that I've covered. In the next module, they are theoretical modules that I will cover within 1 month each. So there is no issue. I will cover your course. Don't worry. Don't take tension. I'm available. And now, these are the various PPTs. Okay, welcome Joseph. These are the various PPTs that is available. I will send you the PPTs. I will share the PPTs with you. For example, I will share only 4 PPTs. No, 8898 69. These are the PPTs that is available. 4th August, 9th. Yeah, I will share with you. These are the 4 PPTs that is available. So I will mail you these 4 PPTs. No, no, no. These 4 PPTs do not contain every thing, but please read this one. If you find comfortable with this, then you can ask to me and I will send you more. But please read one by one, not in a hurry that all the modules, all the PPTs you are able to share. Okay. Yes. Hello. Two, 2005. Yeah, it's okay. It's the latest version. Okay. So I will send you. You can see these PPTs. The mail have been sent to you. All right, all awesome. So that's all for today's session. Thank you so much, everyone. Welcome, all awesome. Bye bye, everyone. In the Monday's class, I will be starting your next topic, that is how to use the WM create function. So bye bye, everyone.